Hello, welcome back to YSERV CSE, and we are on 7-day machine learning challenge and interview question, and this is day 6. And the question of the day is, what are the two branches of dimensionality reduction? So dimensionality reduction is an important machine learning technique to simplify your data by removing irrelevant features. It offers several benefits like reducing complexity, improving computational complexity, improving performance of the model overall, and it also reduces overfitting. And there are two branches of dimensionality reduction. One is a feature selection, another is the feature extraction. Now let's learn these two very briefly. It's an overview. So feature selection is basically, it chooses the subset of the most relevant and important features with respect to the target variable while discarding the less important ones. So it retains only the features that have most significant impact on the target variable. And there are various methods of doing that. So one is the filter method, and the other two are wrapper and embedded. So filter is basically, it uses statistical measures to select features. An example would be like correlation, mutual selection, chi-square test. Wrapper uses machine learning model to evaluate subset of features and select the best performing ones. And the examples would be like forward selection, backward selection, recursive feature elimination, and you have embedded, which where feature selection is built into the model training process. So an example would be like lasso regression, decision tree, feature importance, and so on. So this is going to be an example I have taken from Stack Overflow. So if you look at this, so this uses a decision tree classifier and it uses the feature importance computation. So this line basically. So your model, this is the, what shall I say, features. So there are 1, 2, 3 features and 4 examples, as you can see here. And when this is like executed, here is your feature importance. So the first feature has 0.25 importance with respect to the target variable. The next one has 0.0833. The last feature has 0.04166 and so on. So this is how it happens. And now if I have to give you an example, it would be like, suppose you are analyzing a sales data. So this is the sales data of a store. This is a part of the sales data of a store, say for example, and you are given the day of the week. They are giving you, basically your client is giving you a host of information, and information is like the day of the week, if that day was a holiday, if a discount has been offered on that day, how distant is the competitor, like the store selling same types of product from this store, and then who was the security in charge for the day, and when did the store manager arrived, what was the sale of the day, and so on. So obviously looking into this data, you can make out that who was the security in charge, or when did the store manager arrived, has no bearing on the data sales, because the store will obviously open on its time, whoever be the security in charge or whenever the manager arrives. So if you're using any of these techniques, if you're using feature selection, so most probably these two will be eliminated by your algorithm, right? Now let's move on to feature extraction. So now feature extraction involves creating new features by transforming or combining the original features into a smaller set of uncorrelated or informative features. So this is a bit complicated than that one. It's not a straightaway thing. It transforms the features into new features. So there are two ways of doing it. One is the linear way, and so that in linear way you have algorithm like principal component analysis, or PCA, which computes the eigenvectors of data's covariance matrix, and then eigenvectors with the largest eigenvalues are chosen as the principal components, and then principal components are used to reconstruct the original data. Then you have a linear discriminant analysis, or LDA, which identifies a linear combination of features that separates like different classes. They projects data onto a lower dimensional space. Then it maximizes the separation between the classes. Then you have some non-linear methods where algorithms allows us to separate data that cannot be separated by a straight line. So the first example will be T-distributed stochastic neighbor embedding, or TSNE, which calculates a pairwise similarity between all data points in a higher dimensional space. So now similar objects will get high probability score and the dissimilar objects will be assigned a low probability. Now high dimensional data will be mapped into a low dimensional space and similar probability distribution will be constructed in this low dimensional space. Then we will minimize the difference between the two distributions using gradient descent. And then we have uniform manifold approximation and projection, that is UMAP, where UMAP constructs a high dimensional graph representation of the data. It optimizes a low dimensional graph as similar as possible to this high dimensional graph, and the result will be a low dimensional representation of the data. And then another way of doing it is using autoencoders. So what autoencoders does is it compresses the input data into latent space. Now this latent space is a compressed abstract representation of the data which captures the underlying structure of the original data. So like latent space is a lower dimensional than the original data space, and it captures the most important features of the data while discarding the noise and the redundancies. And then a decoder, it uses this latent space to reconstruct the input data. So I will be covering each of these and also the feature selection part separately, but since this is just an interview question, so I'm not getting into the detail. So now let's, one more thing is, if I have to give you an example, so this is not really an example because this does in a very different way. So if I have to give you a human understandable thing what is going on here is, suppose you are trying to gauge the sale price of an automobile. So you are given many data and like many features of the data set, and these are the say two features like distance traveled and fuel consumption. So what we had seen in feature selection was it was completely like it was discarding the features, but here what will happen is it will combine the two features and it will create a new dimension or a feature which is going to be fuel efficiency, which is distance divided by fuel, and that will be used. So there were two data feature, and now that two data features are combined to create this one. So this is an example just to show you that how this would work, but this is not a true example, or this is not exactly what it does. So this is just an example for your understanding, okay? So now let's move on to the final answer. So the final answer, you can frame it yourself. This is just an example. So the two branches of dimensionality reduction in machine learning are feature selection and feature extraction, where feature selection chooses most important and relevant features from the original dataset, discarding the less useful ones. The goal is to select only those features that have most significant impact on target variables. We can use statistical methods like correlation or chi-square test to filter the important features. There are also machine learning models like forward selection or backward elimination, which selects the best performing features, and then we can use embedded methods like decision tree feature importance to find the importance of each feature in the data set. Feature extraction, on the other hand, transforms the original data into smaller set of uncorrelated data. So basically, it creates new features from the existing ones. There are linear methods like PCA or LDA, or non-linear ones like TSNE or UMAP. Even autoencoders can be used for feature extraction. So basically, feature selection is a simpler way which does not change the features, whereas the feature extraction is more complex since it transforms the original high dimensional data into lower dimensions. So I would highly recommend you to go through like the basic principle of TSNE, PCA, LDA, UMAP, and also like forward selection, backward elimination. I will cover it later, but if you have an interview, if you have to sit for an interview, I will just recommend you to go to at least know the basics of it, because your next question might be from any of these, right? So that's it. And as you know that you're in the 6th day, so you must be knowing that the key points are marked in a different ink. So please go through the whole thing. You can take a screenshot, and that's all for today, and stay tuned for the final day. Thank you for watching.